Hi, everyone. So I'm going to talk about advanced type systems and how the Rust programming language makes it possible for anyone to start using them today. To give you a bit of an outline, I'm going to start by talking about a programming language called Python. Then I'll go over type systems really briefly and finish off by talking about the Rust programming language. There's a link to these slides, but I'm going to switch slides now so you won't have any time to take it down. I started programming about 10 years ago using the Python programming language. I was actually writing games using this 3D modeling and animation software called Blender. These are actually real screenshots of the games that I made about 8 or 9 years ago. So that's how games used to look for anybody who's too young. Python's a great programming language. It's an excellent language for both learning programming and teaching it too. It's got tons of excellent resources online and plenty of documentation. The syntax actually even resembles English for the most part, and you even end up using words like and, or, and not when you write programs. There's lots of companies and products that use Python in production, and it has a huge community with plenty of different libraries for anything that you'd ever want to do. Python is what's known as an interpreted, dynamically typed language. The word interpreted means that there's another program that actually runs your Python program. We call that the Python interpreter. It evaluates each line of your program from top to bottom and produces an error message if something goes wrong. Most programming languages, including Python, try to protect you in case you do something that doesn't make any sense. When someone says that a language is dynamically typed, it means that it'll check to see if your program is correct while it's running. In the code shown on the right, there's an error on the very last line where we try to add some text to a number. And Python will actually go through and evaluate the entire program, and it won't find the error until it tries to run the last line. Keep in mind that big companies use Python to build their products and release them to the public. And imagine if those companies had a user that suddenly experienced an error, something as trivial as this, and the program stopped working. You might lose those users. Now, when you try to add some text to a number, Python produces an error and says that you can't add those two types together. And I've mentioned types a couple of times already, but what are they anyway? I'm not going to go into any programming language theory in this talk. I don't actually know any programming language theory, so that's why. But I think a good way to think about types and type systems is that they're a way to provide more information about your code to a program that can check your code automatically. Python has dynamic types. That means that it figures out the types of everything in your code as it runs through the program. If there's an error, it won't know until it actually gets there. It doesn't even actually have the information necessary to check until it's already at that point in the evaluation. One thing I'd like to point out is that you don't actually need to have your program checked using types. You know, this might seem contrary to the point you probably think I'm trying to make, but the thing is, you can check pretty much everything that a type checker does on your own. Like, humans can check everything that type checkers check. And I know this from years of experience using Python. When you don't have a type checker, you end up looking through your code and checking it yourself. But the thing is, why should you have to? Right? Like, this is one of the main points that I'd like you to take away from this point, or from this talk. Programming can be hard enough without having to make sure that basic things are correct. Humans forget things all the time. Not only that, but it's easy for computers to check a lot of these things automatically. Like, it might take a while, but they can do it, and they won't forget any details, no matter how many times you try to run your program. So why should we spend our time doing something that we can automate away? If we give computers enough information, they can check a ton of details about our programs. Now, I mentioned earlier that a good way to think about type systems is that they provide more information about your code and allow a program to check it automatically. And I'm using Python as an example here, but you should know that a lot of languages are like this. I used Python for 8 years before I discovered Rust, and throughout that time, I loved programming in Python. The thing is, at some point, I realized that there was real value in having confidence that your code works before you actually run it. When you use what's called a statically typed language, your program gets checked before it runs. After that check, you know that a lot of mistakes that you could have made definitely aren't present in your code. All of the languages on the right are developed to help avoid errors before a program is run. And you'll notice that Rust is on that list too. So what makes Rust different from the rest of these languages? Well, Rust is a statically typed compiled language. That means that Rust programs are checked before they're run, and you don't need another program like the Python interpreter in order to run them. Rust is actually able to check your code and run extremely efficiently. Rust is also relatively new. It started development back in 2006, and the first stable release was in 2015. But since its release, Rust has been the most loved programming language on the Stack Overflow Developer Survey for 2 years in a row, in both 2016 and 2017. Rust's community is full of kind, compassionate, and very knowledgeable people. And this has made it so that there are tons of resources for learning Rust and plenty of people to help each other learn every day. Type checkers, type systems provide a way to give a program more information about your code so that your code can be checked automatically. That means that you can be sure about more things before your program even has a chance to run. Rust can actually check a lot of things. It can make sure that when you call a function or use an operator, you pass it the right types of values. Keep in mind that Python and other languages like it do these kinds of checks too. They just can't do them until the program is already running. Rust can also check more advanced things too. It guarantees before a program runs that your program is completely memory safe and without any data races. These things are critical, and some of the most harmful bugs in C and C++ programs have been because those languages can't check the same things as Rust. And writing concurrent code correctly can be really hard, even for the most advanced software developers. But Rust makes it significantly easier by removing the possibility of data races, which can cause subtle bugs that are often impossible to find consistently. Rust is actually one of the first languages of its kind that's able to make these sorts of very advanced guarantees. Now, I unfortunately don't have enough time to explain how Rust does all of this, but you should know that you can even write programs in Rust where it actually becomes impossible to run an incorrect program. You can use the advanced features in the Rust type system to make sure that any potential failures actually fail to type check. It's like teaching the type checker what invalid inputs are and making sure that it always rejects them so your program's correct. Now, that's a kind of confidence that you just can't get in many other languages with different type systems like C, C++, or Java. Rust gives you all of the speed of C and C++ with the memory safety of Java and the expressiveness of Haskell. Now, if you haven't used any of these languages before, you won't know what I'm talking about. But I can guarantee that this is something that the world has never really seen before, but has needed for a really long time. There's a reason that Rust has been the most loved programming language in both years since its release. Rust's syntax is clean and relatively simple in comparison to other languages with similar type systems. That means that, like Python, Rust code can often be easy to read and understand quickly. Rust even has a lot of familiar ideas from languages you might have used before, like Python, C, C++, or Java. The Rust Frequently Asked Questions page even says that we don't employ any particularly cutting-edge technologies. Old, established techniques are better. That means that even though Rust is different from C, C++, or Java, there's enough familiarity to make learning Rust feasible for everyone. You don't need a complete mental readjustment like other languages might require from you. Rust has seen tons of adoption. There's a Friends of Rust page that lists organizations running Rust in production. And there were so many on that page that I didn't even bother trying to fit them all on one slide. In fact, I'm just scrolling through here. There's so many companies on this page, and this is just some of them. That means that there are real tangible benefits to using a language like Rust, and these companies must clearly see that if they're willing to advertise that they're using Rust in their products. Rust makes, the main takeaways that I'd like you to take away from this talk are that Rust makes advanced type systems accessible to everyone by having a great community, a fantastic set of features, and excellent learning resources. Type systems are good, important parts of programming languages that will reduce the amount of problems in your code. And we should be using advanced type systems over the ones with fewer features, like in Java, C, or C++. The more checking that computers can do for us, the less we have to rely on ourselves to make sure that everything is right after every single change. Now, none of this is an issue of which syntax is the prettiest or which language is my favorite. It's Rust, by the way. It's about the principles and techniques that the language uses to help you write safe and correct code. That's really the point here. Now, if you'd like to learn Rust, there are a whole bunch of resources available. This is just a small list of some of them. A couple of these resources are also good for people who are new to programming as well. You can check out the links on this slide, or you can use your favorite search engine to look up more. I'm also working on designing a course for people looking to learn programming completely from scratch. I'll be teaching the Rust programming language, and no programming experience will be required at all. It's not ready for use yet, but check back in a couple of weeks, and some lessons should start to appear on the website. Thank you. If you'd like to follow me, my Twitter's on this slide.